The next part of the chemical reactions unit is called stoichiometry. Now we're going to talk about if you do want to do a reaction, let's say in lab, if I start with 5 grams of a reactant, how many grams of products do I make? So we're talking about calculations about quantities in chemical reactions. But before we can do that, let's just review a couple of things. First of all, the concept of a mole. Remember, a mole is a huge number, 6.02 times 10 to the 23rd. The reason it's important is because atoms are so tiny that we can't really talk about individual atoms or molecules reacting. What we want to do is scale it all up. So instead of talking about one atom of A or B, we're going to talk about moles worth of atoms. One of the things we had talked about, remember mole central station, the volume of 1 mole of any gas, doesn't matter what it is, at STP. Now STP stands for standard temperature and pressure. The actual values are given in the first table in your reference table. So the volume of 1 mole of any gas at STP is, and we had talked about this number, 22.4 liters. That's actually called the law of molar volume. Again, 1 mole of any gas. So the other term we had talked about was GMM, or gram formula mass, gram molar mass. That is basically the mass of the compound of all the individual atoms all added up. So let's just look at a quick review of mole central station. So remember, we had moles in the middle. I had mass in grams. If I want to go between mass and grams, I need to either multiply or divide by GMM, gram molar mass. I have volume. Volume is always going to be in liters. If I want to go between moles and volume, I'm always going to multiply by 22.4. Again, this is liters per mole. GMM is grams per mole. Those are the units. The other part was number of particles or atoms. Those you are going to either multiply or divide by Avogadro's number, 6.02 times 10 to the 23rd. Here the units are molecules per mole. Now remember, all arrows going away from moles, you're multiplying. So if I want to find the mass of 2 moles of something, it's 2 times the GMM. And coming over, it's dividing. So you're going to divide here. So again, this is just a review. Now we're going to start talking about actual chemical reactions. Here's an equation, and the one thing that we have talked about is balancing chemical equations. So to balance it, I would put a 2 here, a 3 here to balance out the hydrogens. And now when you look at it, I have 4 oxygens and I have 3 oxygens. So I have a total of 7 oxygens. Now here, I need a number to even it out. And here's another technique that you can use. Obviously, you can't have 3.5 atoms of something. So instead of that, write it as 7 over 2, 3.5. Now if you multiply everything by 2, I would get 2. 7 over 2 times 2 is just 7. This becomes 4, and this becomes 6. Now, let's just, this is 2, 7, 4, 6. Now, what do these coefficients actually mean? Well, here, the coefficients mean if I have 2 molecules of C2H6, they're going to react with 7 molecules of O2, and as a result, they are going to give me 4 molecules of CO2 and 6 molecules of water. However, we are talking about tiny molecules, tiny atoms, and so these coefficients are also going to represent moles worth of substances. So again, when we are scaling it up, we are also talking about number of moles, not just number of particles. So what we can do is we can compare mole ratios. So for example, for every 2 moles of C2H6, I would make 4 moles of CO2. So we're talking about mole ratios. These are the ratios that you have the reactants to products. You can come up with this ratio for anything. You can say 7 moles of O2. If you're using that, you get 6 moles of water. So this is giving you a mole-to-mole ratio of different reactants or products in the chemical reaction. So here is the same equation, and remember the balancing was you have 2, 7, 4, 6. And the question is, how many moles of water will be produced from the complete combustion of 3 moles of C2H6? Again, you can look at how many moles of water, so this is one part, and you're given C2H6, so you're looking at the ratio. The ratio is 2 to 6. Here's a basic steps. Here are basic steps that you can use to solve any equation. First thing, balance the equation, which we just did. Write the known and the unknown above its formula. So here are 3 moles of C2H6, so I'm going to write 3 moles above C2H6. My question is how many moles of water, so I'm going to put an X over water. That's what I'm looking for. Now there are 2 ways to do it. The simple way to do it is this. If you're talking about a mole ratio, here are the ratios that you're going to have. 3 over 2 equals X over 6. So you can say 3 moles of C2H6 over 2 moles of C2H6. So how many moles of water do you have if, based on the balanced chemical equation, you have 6 moles of water? So this 2 to 6 ratio of C2H6 to water is based on the balanced chemical equation, and this is the question, what you're looking for. If you write the values, the known and unknown, above their formulas, it sets up that mole ratio for you. So in this case, X is going to be 9 moles of water. It's very important for you to put the unit and the compound now, because you can be talking about any of the reactants or the products. So here's an example that we're going to try. First things first, you have to balance the chemical equation. So let's balance the nitrogen first, 2. Then let's balance the hydrogen. And now let's go back and check to make sure I have 2 nitrogens, 6 hydrogens, 2 nitrogens, 6 hydrogens. So now it's fine. How many moles of H2, so as soon as you see that, write down the X, are used to produce 7.24 moles of ammonia? 7.24 moles. Again, if the number that's given to you and the number that you're looking for is in moles, it sets up the ratio for you right there. So X over 3 equals 7.24 over 2. Again, let's put the units on there. Moles of H2, moles of H2. Here we're talking about moles of ammonia, moles of ammonia. So again, these are the things that are going to cancel out, and you're going to be left with an answer for moles of H2. Again, you're just going to solve for X, and in this case, X is going to end up being 10.9 moles. And again, also put the compound that you're looking for. That's going to be H2. I want to show you one other way, which is, I guess, the correct way, which is using dimensional analysis. So the question you're asked is, how many moles of H2 can you get from 7.24 moles of ammonia? So here is ammonia. Now, based on the balanced chemical equation, I have, for every 2 moles of ammonia, I need 3 moles of H2. So if this is in the numerator, I need moles of ammonia in the denominator, so I could cancel it out. So for every 2 moles of ammonia, I need 3 moles of H2. Moles of ammonia cancel. 7.24 times 3 divided by 2, again, I would get 10.9 moles of H2. Either way is correct. The dimensional analysis obviously is a better technique. Now, what about if we also include grams? In this case, it's the same process, but now we're actually going to include grams as well. So we're going to do the same thing like we did before. We have how many grams of LIBR, so now it's X grams, and the number that's given to you is 42.0 grams. When we set up that ratio in the last few problems, we were talking about a mole ratio. Now, we don't have a mole ratio. Think about the mole central station, so I have moles, I have mass in grams. This part is true for each one for lithium and LIBR. So as far as a way to get a value, you kind of have to do a couple of steps. First, you have to be able to convert grams to moles, so grams of X, grams of lithium to moles of lithium, and again, for that you need GMM. Then you can go from a 2 to 2 mole ratio, so now that's your connection between lithium and lithium bromide in the equation. That's from your coefficient ratio of your balanced chemical equation, and then you can convert lithium bromide to grams. In this case, you really have to go from grams to moles first, then mole to mole, and then mole to grams. So this is much better with dimensional analysis. So the question is, how many grams of LIBR are formed if you're starting with 42.0 grams of lithium? The only connection you have between lithium and LIBR is the mole ratio from the balanced chemical equation. So the first thing you have to do is convert grams of lithium to moles of lithium. So divide by the GMM, grams of lithium, moles of lithium. This is just the GMM. 1 mole of lithium has a mass of 6.9 grams. Now your connection, oh wait, this cancels. Now your connection between moles of lithium to moles of LIBR. This is based on your balanced chemical equation. For every 2 moles of lithium, I produce 2 moles of LIBR. Moles of lithium cancel. Now the last part we have to do is convert moles of LIBR to grams of LIBR. Here you're talking about the GMM. So I have, for every 1 mole of LIBR, you can look up the mass, and the mass happens to be 86.8 grams. When, again, now moles of lithium bromide cancel out, you're left with grams of lithium bromide. And the answer in this case turns out to be 804 grams of LIBR. So that's going to be your answer for this problem. Again, you can't just go from grams to grams. You have to go from grams to mole, just like you would in mole central station. Then you would have a mole to mole ratio. That's your connection between Li and LIBR. And then you would have to convert moles of lithium bromide to now grams of lithium bromide. So your assignment tonight is to try this problem. Again, how many moles of LIBR? So this time you don't have to go to the entire gram. So here is your process. Grams of X, you can convert moles to moles of X. So grams to moles, you know, has to do with GMM. Your mole to mole ratio from the balanced chemical equation is your connection between 2 components of the reaction. And then you can go from moles to grams. In this case, you don't have to go the whole way because you're already given, you're asked for how many moles of LIBR. So that's your moles, and this is 42.0 grams of lithium. So you have to go from grams to moles of lithium and then a mole to mole ratio. You don't have to go to grams of LIBR because that's not what's asked. So your assignment today is to figure out this problem, and I'll give you the answer in class tomorrow.